intro.
Okay, so next problem natin is given ka ng beam kung saan you have a boundary condition. So yung tensile flexural stress niya is only limited to 40 megapascal and yung compressive flexural stress is only limited to 100 megapascal. So we need to determine what is the value of the uniform load omega O or omega sub O. Okay, so as you can see, meron naman tayong symmetrical loading dito. Meaning, kung anong makikita mo doon sa kabila, yun din yung makikita mo sa kabila. Kung ano yung mga distances niya, yun lang din yun. So therefore, again, gaya nga nasabi ko, the first step that we need to do is to determine the reactions doon sa mga support. So let's just name this as reaction at A or point A and this one as point B. So you have a uniform load acting downwards, so therefore the value of your reactions will be in upward direction. So yung value ng RA natin and RB will be in terms of the omega sub O. Kasi ito nga yung pinapahanap sa atin. Okay, so ang gawin mo na lang para mas madali, since symmetrical naman yung loading natin. So itong omega sub O mo, i-multiply mo lang ng total span and then i-divide natin ng 2. So mangyayari, paghahatiin lang natin yung dalawa, itong uniform load na minultiply mo ng total span niya. So ano ba yan? So 1.2 times 2 plus 3, that is 5.4 divided by 2. So that is 2.7. So ito pala has a value of 2.7 ng omega sub O. So as for RD, 2.7 omega sub O. So next, we will now plot the shear and moment diagram ng ating beam. So again, i-project mo lang to pababa. So ano nga yung sunod sa original loading? So we have here the shear diagram and then followed by the moment diagram. Okay, so ano sabi doon sa figure natin? So first, coming up this point, meron ka daw uniform load acting downward. So ito magiging ano? So itong 1.2 multiply mo lang ng omega, or that will be 1.2 omega sub O. So since pababa yan, and then itong loading natin is categorized as 0 degree curve, so ito magiging first degree or magiging triangle lang. And then next, at point A, ang sabi sa kanya, tataas ako ng 2.7. So coming from negative 1.2, taas ka ng 2.7 or 1.2 plus 2.7, so that will be 1.5. So magiging 1.5 ka dito, 1.5 omega sub O. And then coming from point A to point B, you have a uniform load acting at 3 meter span. So minus 3 omega sub O, or that will be what? So that will be negative 1.5 omega sub O. And then next, addan mo ng 2.7. So negative 1.5. Negative 1.5 plus 2.7, that will be 1.2. So 1.2 omega sub O. And then, subtract mo lang itong area nito. Or that will be omega minus 1.2. So that will be, or 1.2 omega sub O minus 1.2 ng omega sub O. So that will be 0. Okay, so tama naman yung ating shear diagram since nag-0 naman siya. Okay, so kung mapapansin natin dito, ito 1.5 omega sub O. Ito 1.5 omega sub O. Ibig sabihin, kung ito ay 3, and then equal rin naman siya, so this will be a distance of 1.5. Okay, so by analysis alone, pwede mo nang malaman yung distance niya. But if you're unsure o hindi ka sigurado dito sa value na to, you can still use the concept of ratio and proportion. Okay, so since we're done with the shear diagram, we can now check or we can now solve or draw the moment diagram. So again, coming at this point, starting from 0, so ito, kunin mo lang yung area ng triangle na to, or that will be 1/2 base times height. Ang base mo is 1.2 times the height of 1.2 also. So that will be 0.72 ng omega. So, again, para malaman mo yung shape, hindi kasi natin alam kung pa ganun, pabundok, or pa-concave. Ano ba? So again, hanapin mong maximum and minimum value dito. So between 0 and 1.2, which is the maximum, which is the minimum. So ito yung minimum, and then this is the maximum. So since pababa yan, so pababa rin dapat ito. So ito is magiging 0.72 ng omega sub O. Okay, next will be for this point. So meron kang triangle, which is at the upper part ng ating shear plane. So, i-add mo yung value nun. So, negative 0.72 plus 1/2 of the base na 1.5 times 1.5. So, the value would be 0.405. So, alamin mo yung shape niya. So, between these two value, 1.5 and 0, which is maximum and which is minimum. So, maximum is 1.5. So, vertical line and then horizontal line. So, since ito is positive, ibig sabihin na sa upper part siya ng iyong moment plane natin. Or, so horizontal to, pag dugsungin mo lang, ayun. So, ang value dito is 0.405 ng omega sub O. Okay, next. So, next will be for this point. So, from this up to this point. Okay, so since nasa baba siya, so coming from 0.405, susubtract mo lang yung area ng triangle na to. Or that will be 1/2 of the base na 1.5 times height na 1.5 ng omega. Or that will be 0.72. So parang pareho lang nito, ano. So again, minimum, maximum. So negative siya, so nasa baba ito. Ayun. So 0.72 omega sub O. And then last will be for this area. So, coming from 0.72, add mo lang yung area ng triangle na to. So, plus 1/2 of 1.2 times 1.2. So, that will be equals to 0. So, maximum, minimum. Ayan. So, this will be the shape of our moment diagram. Again, this moment diagram, the shape of this is essential para malaman natin kung ano magiging shape ng deformation dito. Ang daming dumaan na trap. Okay, so ang sabi dito, ito nasa baba. Therefore, ito sa taas. So, magde-deform siya ng paganyan. And then, ito, sa portion na to, nasa taas siya. Therefore, dito, bababa sa point na to. And then, dito, ganun din, tataas ulit. Ayan. So, ayan. So, with that, malalaman natin kung alin yung side na tension and compression. But first, ano yung mga value ng maximum positive moment and maximum negative moment? So, dalawa lang naman yan, ano? So, knowing that ito will be the maximum positive value, and since pareho lang naman yan, maalis dyan sa dalawa. So, this is the negative moment, this is the positive moment. Okay, next, anong gagawin? Analyze natin ito, yung shape ng deflection niya. So, again, kapag nakaganyan ka, which side o which part of the beam yung nagkaroon ng tension and compression. So, ang compression mo is itong upper part. So, yung white top will undergo compression. So, itong upper portion, lagay ko na lang dito. So, that is compression. And then, yung ilalim, ito yung nabata. So, that will be tension. And then, dito, since pag ganito yung deflection ng yung beam, so, anong na-compress? Di ba yung baba? So, ang compression mo, or yung C, is bottom. And then, yung iyong tension will be the Y top, or Y sub T. Okay, so since we have now the value of the moment, and knowing that the equation for the flexural stress, or sigma F, is equals to MC over I. From where C is either Y top or Y bottom. So the next step is to determine this centroid of this composite area, categorized as unsymmetrical. So, assume natin kung nasaan yung neutral axis niya o yung location ng centroidal x-axis. So, I will say na assume natin na nandito siya banda. Okay, so, this is the neutral axis. So, the first step that we need to do in order to solve for the location of the centroid is to determine the total area of this composite figure. Ano bang gusto nyo gawin nyo? Anong gusto nyo gawin nyo? Ano bang gusto nyo gawin natin? Sumakit ba naman na? Gawin nating dagdag bawas. Or huwag nating hatiin sa mga triangle. So, ang gawin natin, isang malaking rectangle minus itong rectangle na to. Ayos ba? So, ito is magiging, anong size ito? So, kung ito ay 20, 260, this is 240. And then, yung lapad niya, ito. So, that will be 100 minus 20. So, this will be 80. Okay, so the total area. So, to solve for that, so that will be area ng big rectangle. So, minus area nung small rectangle. Ito. So, para mapalabas natin yung yan. Okay, so total area. So, anayin ko na lang. Pinakita ko lang ha. So, the total area, so that will be area ng rectangle. So, 100 times 260. And then minus yung smaller triangle. So, 80 minus 80 times 240. So, 100 times 260 minus 80 times 240. So, that is equivalent to 6,800 mm squared. Okay, so ang gawin na lang nating reference point is yung y-top. Itong axis na to. Ano ba mas madali? Ito na lang, y-bottom pala, para dikit. Ano? Ito yung x, ito yung neutral axis. So, with reference with the x-axis, so area total, so mahanap natin una will be the y-bottom. Y-bot. Area total multiplied by y-bottom, so equals dun sa area ng big rectangle, so that is 100 times 260 multiplied by ano yung centroid ng iyong big rectangle. So kalahati lang ng 260 na. Or gawin ko na lang 260 squared over 2. Huwag malilito, diniretso ko lang. So 100 times 260 area times 260 over 2 yung centroid. And then minus 80 times, ayan din, ganun din, 240 squared over 2. So the answer will be, so 100 times 260 squared divide 2 minus 80 times 240 squared divide 2. And then divide the total area. So the y bottom will be equals to 158.2353. So this is in mm. And to solve for y top, so that will be just equals to 216 minus the y bottom. So that is equals to what? 101. Okay, so tama naman yung assume natin. Ano? So 101.7647 mm. Okay, so meron na tayong value ng y top and y bottom. The last thing that we need to do is to solve for the value of your I, or the moment of inertia with respect to the neutral axis. Okay, so let's start. Unahin natin yung big rectangle mo. So, alin ba yung base natin? 100 multiplied by 260 cube over 12. And then plus the area, 100 times 260, and then times the distance. So, ang distance niya, so, ano ba yung ano natin? So, that will be, so, 260, kalahati ng 260, so, 130. And then minus the, ito y bottom. Sorry. So, y bottom muna pala. So, y bottom minus 130. Kasi ito yung centroid ng big rectangle. Ito. So, ito pala si 130. So, yung y bottom natin mas malaki. Ito yung distance na kailangan natin. Ano? But anyway, sabi nga doon sa moment of inertia, wala namang problema kung mauna yung 130 mo minus yung y bottom, 158.2353. Kasi nga, naka-squared siya. So, kahit anong mangyari, magiging positive siya. Again, ang nag-i-indicate ng sign dito is the sign ng iyong area. Kung ima-minus mo ba siya o isusubtract. Pareho lang pala. Kung i-add mo or isusubtract. Okay? So, again, walang problema kung magkabaligtad to. Since i-squared mo siya, the distance will still be positive. Okay, so minus yung area ng rectangle na to. Or that will be, so ang base mo is 80 times 240 cubed over 12. And then, ano na lang natin, kulong natin sa parenthesis. Plus area, so 80 times 240 multiplied by the distance na. So, y bottom, so 158.2353 minus yung centroid ng smaller rectangle. So, if the height is 240, ang kalahati nun will be 120. Grabe, kinalag yun. So, that is 120 square. Okay, so what will be the value of the moment of inertia with respect to the neutral axis? So 100 times 260 cubed by 12 plus 100 times 260 times 130 minus 158.2353 squared. And then minus quantity of 80 times 240 cubed by 12 plus 80 times 240 times 158.2353 minus 120 squared. So that will be ilan po? So 469,65490.2. Nagkamali pala ako dito ng code. Ano nga ito? Iba kasi yung calc yung gamit ko dito. Ayun, sorry. Or that can be written also as 46.9655 times 10 to the 6. So, mm raised to 4. Okay, so kompleto na tayo ng component. We can now check the boundary condition. Again, ang pinapahanap is yung si omega sub O. So, let's start first with the tension. O, the tensile stress. So, yung tensile stress mo, so, considering sigma t is to 40 megapascal. Okay, so, ano nga kapag tension? Ano? Ang mabababa. Ang gagamitin pala muna natin na checking is using the moment. So first, considering the positive moment. Wala, naubos na ng tinta. Considering the positive moment na 0.405 ng omega sub O. So, ang gawin na lang natin dito, ang hahanapin ko sagot nito is in terms of kilonewton per meter. So, ibig sabihin nito, I need to multiply this 1,000 squared para masatisfy ko yung unit na kilonewton per meter. Okay, so considering the positive moment, so ano nga yung positive kapag moment dito, ang compression mo is top, the tension is in bottom. So, ano nga yung ating compression? So, 100. So, ang compressive stress is 100. Is equals to moment, ito. So, 0.405 ng omega sub O multiplied by 1,000 squared. So, kapag positive moment, so, compression, top. So, ano yung Y top? So, 101.7647. So, MC over I. So, divided by this 46.9655 times 10 to the 6 mm raised to 4. So, what will be the value of omega sub O? So, ito, store ko lang to Paano ba mag-store nga dito sa store? Ayan. Okay, so solve natin. So 100 times the alpha divided by 0.405 divided by 1000 squared divided by 101.7647. Okay, so the answer is 113.9532 kilonewton per meter. Okay, so this is the answer considering the positive moment under the compression. Okay, next will be for tension. So ito is compression. Next, we will now check the tension. So ang tension mo, sabi ang the allowable stress dyan is 40 megapascal. So that is equals to sa positive moment na 0.405 ng omega sub O times 1,000 squared. So ano nga kapag tension sa positive moment, tapat-tapatan lang. So ang tension is yung bottom or 158.2353 over 46.9655 times 10 to the 6 mm raised to 4. So what is the uniform load? Tama ba na ang papalitan ko lang is ito at saka yung Y bottom. So this is 158.2353. Oh, 2353. Okay, so the answer is 29.3144 kilonewton per meter. Okay, so we're done with the positive moment. So hindi pa dito natatapos. We need also to check the negative, the maximum negative moment. Okay, so this time considering the negative moment, which is equals to 0.72 ng omega sub O. Again, you need to multiply this one by 1,000 squared para maging kilonewton per meter yung sagot. Okay, so unahin natin ulit sa compressive. So ang boundary condition natin, ang sabi the allowable stress is 100 megapascal. So ang moment mo, ito given 0.72 ng omega multiplied by 1,000 squared. So ano nga, alin nga ang compressive kapag negative moment? So kabaligtaran lang nito, no? Kung kanina yung top, ngayon yung bottom yung na-undergo ng compression. So Y bottom, so 158.2353 divided by the moment of inertia na 46.9655 times 10 to the 6. Okay, so what is the value of the uniform load? So, ano bang mangyayari? Ito, papalitan, 100. Ito, so 0.72. Tapos, magiging 158. So this one will have an answer of 41.2233 so kilonewton per meter. And then the last will be for the tension category. So ang tension mo is 40 megapascal. So equal sa 0.72. Ang papalitan mo lang naman is ito. Yung Y bottom. Yung omega sub O times 1,000 squared multiply by. So ano nga ang na-undergo ng tension kapag negative moment? So yung Y top, or that will be 101.7647 over the moment of inertia na 46.9655 times 10 to the 6. So what is the uniform load? So ito lang yung papalitan, magiging 40 and then times alpha 72, okay. Tsaka yung Y bottom, magiging Y top yun. So that will be 25.6395 kilonewton per meter. Okay, so kung makikita nyo, meron tayong 4 na sagot. Ito naman na ituro ko na rin sa inyo kung alin nyo i-consider the maximum safe uniform load na pwede natin ma-apply in order to satisfy these two conditions. The allowable tensile stress is 40 megapascal and the allowable compressive stress is 100 megapascal. Again, with these 4 different values of the uniform load. Which of these is the maximum safe value na i-consider? Is it 113.9532 or 29.3144 or 41.2233 or 25.6395? So which is the maximum safe value? Okay, so again, kapag load yung pinag-uusapan at maraming pagpipilian, ang pipiliin is yung pinaka maliit. Though sinabi na maximum, the maximum value will still be the smallest value. So kung hindi kayo sure o nakalimutan nyo to, so pili kayo dito. I-resolve nyo siya using this 4. Pero kung ako sa inyo, piliin nyo na lang, kung nakalimutan nyo yung concept na yan, piliin nyo yung pinakamalaki yung pinakamaliit. Malabo na naman na nasa gitna yan. Ano? So i-resolve nyo using itong dalawa. Once naman hindi nag-satisfy sa condition na to, o may lumampas sa mga value na to, ibig sabihin hindi yun yung tamang sagot. Dapat ang mapapalabas mo is exact lang nito, o kung lumampas ka man ng counting decimal, 0.00 something lang, okay lang yun, kasi that is because of rounding off. Hindi talaga siya sasakto. Or pwede mangyari 99.9999 something, parang alcohol lang. Okay, or again, kapag lumampas, ibig sabihin hindi yun yung tamang sagot. Dapat mas mali ka lang dito or yung exact value yung makukuha mo if you're going to check using these two values. So again, the final answer will be 25.639. Okay, so let's proceed to the next problem.